Morning, everyone. Could you please confirm, are you guys able to hear me?
Yes, we can able to hear you.
Yes. Okay. So all the recording videos, I'm going to say whatever the sessions it's happened, all the sessions, everything is uploaded into the YouTube channel. It is available. You guys can get it from the, or you can watch from the YouTube channel. Let me just going to show you that. Let me go to this. Anyone joined newly here today? Go with this. So here I uploaded this, the first video, AWS roadmap, AWS DevOps roadmap. The second, yesterday, whatever the session we have discussed about the Jenkins CI/CD pipeline to check the code quality and how we can deploy the application in this particular Tomcat server. That is also we have discussed about, we have uploaded in this YouTube channel. If you would like to recap or you wanted to go back once again, you guys can go back to this YouTube channel later. Okay. So as a part of the demo session today, we'll be discussing about the how we can able to create load balancer, and we'll see that the how it is distribute the traffic between the servers. So it is also very important topic because usually we used to use something in load balancer for all the applications. Let me just going to explain about the how it is going to work for us. Okay, so let's start our session. And first we'll discussing about the how to set up the servers, and also we'll discussing about the how we can deploy the application inside the EC2 instances. We'll see that how to attach the load balance to this particular instances. That is what we are trying to discussing about. First, let's talk about the how we can do it right now. So first one. So what I can say. So let's for example, we have a software development team, and we know that the software development team is going to push the source code into the GitHub repository. This is nothing but the development team, and they're going to push the code into the GitHub repository. There is a noise. Let me mute someone. It is okay. Okay. Uh, the first last two sessions we have seen with the Jenkins CI/CD pipelines, how to configure everything, but we'll see something different on AWS today session. And this is what we have to really see, that we have a software development team. We have a software development team. And here it is nothing but we have a GitHub repository where we can actually store your code. Now, what I will do, I will just take this. Okay. I'll try to configure the two servers. This is one server which I'm going to configure it. And I'll take two servers. Now, in these servers, what I will do, I will deploy one application. And I'll just go with the other server as well. I'm configuring the another server on AWS by using EC2 instances. Here, I will deploy the another server, another application. Okay. Now, see what is the use case basically. Why do you want to go with the load balancer means? See, for example, as of now, let's take the Flipkart application, or you take any e-commerce application. I'll go the Flipkart application. This is nothing but our Flipkart application, and we deployed in the server. So let's say, for example, we have only one server, and here we have end users. Okay, this is nothing but end users. End users usually they are going to access the applications by using the URLs. That's we know that. When I go to here, this is my end user. Let me go to here. Let me just bring it up. The actor. Okay. So let's say he is the end user, and whenever we would like to access the application, we are going to provide the URL. So these servers are running in my production environment, so that whenever the customer is going to open the web browser, and if we hit www.flipkart.com, it is www.flipkart.com. Now the request will not go directly to the server. I'm talking about the request. It will not go directly to the servers. Then how it will go to the servers here? See, we have something, it is called a load balancer between these servers. This is nothing but load balancer where we can set up here. This is my load balancer. Okay. And if I go here, if I search for the load balancer, let me just take this one. I'll put here it is. Okay. And I'll just go to here. I'll take it up the instance here. This is my incident server. Let me take this one. I'll keep here this. And this is one more server. Okay. There are two servers we are having right now. There is one load balancer we are having. So whenever you're trying to access any kind of application, the first request, it has to go to the load balancer. The first request go to the load balancer. Now the load balancer what it will do it. Directly it is going to send the request to my servers to get the response to the request. No. Let's assume that we have only one server right now. And whenever we send the request, first my load balancer will accept the incoming traffic. What are the traffic which is coming towards my application? The first request go to the load balancer. That means the first try to understanding about what is the functionality of a load balancer. The first functionality of a load balancer is first one. It is going to accept the incoming traffic. The first, it is going to accept the incoming traffic which is coming towards my application. That is the first responsibilities of a load balancer. Now, after that, before it is going to route the traffic to a particular server where exactly your application is running, what it will do, second point, it is going to check the health of the server. So before it is going to send the traffic to a particular server, it is going to check the health of the server. Okay. So now, when just go to here, if my server is active and running status, if it is healthy, then what will do? My load balancer will route the traffic to this particular server. So let's say, for example, we have only one server right now. When we have one server, when you keep sending all the traffic to a single server, what it is going to be happen? You are going to get application downtime due to the traffic. If it is not for going to perform the auto scaling, like scale up and scale down, definitely my application is going to be down. Because if my server is not able to handle the traffic which is coming towards my application, definitely it is going to be getting downtime. So if you want to perform the auto scaling and we want to distribute the traffic between the servers, definitely we need a load balancers. See, there are two different types of load balancers will be having. One is nothing but L4 load balancer. One is nothing but L7 load balancer. This I'll talk about later when we're discussing about the actual classes. Right now, we'll try to understanding about what is meant by L7 load balancer. L7 is nothing but application load balancer, which is going to be configured on the layer 7. What are the traffic which is coming towards my application? It is called HTTP and HTTPS. It is going to distribute a traffic to my servers. So the first request go to the first server, the second request go to second server. See, based on the algorithms which we are having the load balancer, based on that it is going to distribute the traffic between the different servers. Now this is architecture which we have to understand. Now based on this, what we can do, we are trying to understanding about the how to set up it is. So whenever you're trying to working for any organization, so what are the whatever you're trying to have the resources, what are the resources we are having right now? All the resources you're trying to keep inside the VPC. So VPC stands for the virtual private cloud. And here you just look at my screen. Inside the VPC only you're trying to manage all the resources. You create EC2 instances, or you create load balancers, or you create network load balancer, you create a cluster, you do whatever it may be. Everything we are trying to keep inside the VPCs. Inside the VPCs we'll be having a subnets. Inside subnets only we are trying to keep it, we are trying to creating all these resources. Okay. Now first we'll see about the how to configure these two servers. We'll go with the step-by-step process. First, we'll go with the server configurations. We'll try to deploy applications. After that, we'll see about the how to configure this load balancer. Let me go to this my AWS account. Now here first, let me go with this now. Send to the console. Log into my AWS account. Click on the next now. Let me enter the password. Let me go to this AWS account. I'll choose a region. I think I'll go with the North California. Let me click on the EC2 now. I want to check that is there any EC2 instance running it is. Okay, I don't have any EC2 instances now. Let me create one EC2 instance here. So click on the launch instance. Now first I'll go with this now. I'll go with this first. It is called as a web server. The name could be anything. And after that, I'll try to configure the Amazon Linux here. The last session we have seen, I think, how to configure on the Red Hat, how to configure on the Amazon Linux. I'll go with this Amazon Linux server right now. And here I'll go with the instance type it is. I don't require the 2 CPUs and 4 GB RAM. Will be go with the 1 CPU and 1 GB RAM. That is absolutely fine. And I'll require the key pair. So here the key pair we have to set up, let's for example, City Jenkins is my key pair. After that, I'm not going to setting up my VPCs. I'm not going to setting up any subnets right now. This is we'll discussing about later. So now after that, what I can do, I'll come to this option here, configure storage. Now the storage, let's for example, it is 30 GB here. And the number of instances we require only one instance. Okay. Now click on two instances we required. So I'll make it two here. Two instances I require with the same configurations. With the same configuration required. Now click on the launch instance now. So how many instances you are going to launching right now? Two instances you are going to launching here. Let me go to here. Now we have two instances. Click on the view all instances here. Now click on the refresh here. Now go to this and rename this particular instances names. Let's say here it is a web server 1. Now we configure the two servers. One is the web server, another one is the web server 1. Now click on the refresh here. The first, let me try to connect the one server. So we know that whenever you want to connect these servers, we need a putty software. Now I'm trying to connecting all my instances with the help of the putty. Let's try to copy this one and go to the putty. Let me go with the putty.exe. Go with the control V. Go to appearance. Click on the change. And here we have to go with the 14. And here, let me go with this now. Connection here. Provide the 60. Now after this, go to SSH, authorization, credentials. Now click on the browse. I've just tried to provide the Citibank keypad. Click on open. I'm trying to accept my instances. Let me go to here. The first we have to convert this instance as a web server. See, whenever you want to deploy the applications, we need a web servers. So there is something it is called as the three-tier architectures. Let me explain in the next session what is the three-tier architecture. Let's go with the sudo m update -y. I'm trying to updating my operating system here. Don't worry about the commands, everything. When you're discussing about Linux sessions, I'll be covering about all these commands here. First, I'm trying to updating my operating system. Okay. Now we have to understanding about the what is mean by web server. So why do you require the web server? That is, we have to understanding about the why do you require the web server it is. Let me go to now and try to understanding about the what is web server. See, we should have the idea about the what is web server, what is application server, and what is mean by database server. So why you are going to use all these three things. So let's try to understanding about what is web server. See, web server is a computer software and it is underlying the hardware and accept the request by HTTP or listen with help of the HTTP request. That means if we just go with the more details about and try to understanding about what is meant by web server. So whenever you want to deploy the applications, all the web pages, what are the web pages we are having? All the web pages are going to be stored inside my web server. You see that if I just go to now, whenever you send a request here, the request go to my web server. In a web server, where exactly we contain the all the web pages. What are the application which we are talking about? In all the applications which will having inside my web server. So this is my web server. It contains all the web pages. Now we have to convert this instance as a web server. So whenever you connect, whenever you try to connect this instance as a web server, and here, whenever you send the request here, you look at my screen. Whenever you send a request, the request go to internet. From internet, you go to a specific server URL, whatever you are giving it is. From this particular server, whatever we convert to the web server, it is give a response. So the response we can able to see in this particular end users. This is what basically we have to understanding about the how we can able to understanding about this particular end users. Now after that, let me just showcase you that how practically you are trying to implement it is. Now we have to convert this web server. Now, what are the different types of web servers we are having? So we have different types of web servers. For example, if you want to convert your instance on the AWS, for example, you have the you want to install the web server on the Windows machine. So that time we have to go with the Microsoft IaaS. And if you want to, for example, if you want to install instance on Linux machines, we have to go with this Apache HTTP server product, or we have to go with this Nginx, or we have to go with this Apache Tomcat. So now we are going to discussing about the server. The server, what we can call it as a HTTP web server. HTTP stands for the a hypertext transfer protocol. So we know that what is my hypertext transfer protocol, and now here HTTP stands for the hypertext transfer protocol, and D stands for the daemon. D stands for the daemon. So what is meant by a daemon here? See, daemon, it is going to act as a server. Whenever you send a request here, it is giving the response to your request. This is what basically we have to understanding about what is meant by daemon here. So it is a hypertext transfer, the protocol, and D stands for the daemon. It is going to act as a web server in the background. Whenever you send a request, it is giving the response to your request. Let's try to understanding about the what exactly mean by web server and what is mean by HTTPD, and we'll see that how to configure this server as a web server. Let me go to here, and here I'm just trying to open the, yes. Let's try to understanding about the definition here. So come down here and try to understand. A web server is a program that uses the HTTP hypertext transfer protocol to serve the files that from the web pages to users in the response to the request. Whenever you send the request, it is giving a response to your request. Now here, these are the different types of web servers which we have seen, like Apache HTTP server, Internet Information Service, Nginx server. We have HTTPD by the Apache server. Now Apache, if you come down, what is HTTPD? HTTPD stands for the daemon. See, it is a software program that runs in a background as a web server. It waits for the incoming request, server request. The daemon answers the request and serve the hypertext and multimedia documents over the internet. This point is very important. It waits for the incoming server request. The daemon answered the request and serve the hypertext and multimedia documents over the internet using HTTP. This is what basically we have to understanding about what is meant by HTTPD, hypertext transfer protocol. D stands for the daemon. Now we have to understanding about the how to convert this instance as a web server. See, it depends on the which OS you are using. It is going to support different web servers. See, for example, if I go with Amazon X, it is going to support only HTTPD. It doesn't support the Apache 2. When I go to Ubuntu, it will support only Apache 2. It doesn't support the HTTPD. Like, depends on the which operating system you are using, and that it is going to be changed the which web server we have to use. Now I'm trying to configure my web server now. So type the command called, let's say for example, let me go to this and I try to install the web server. If you type the command called install httpd-y, I'm trying to installing web server now. Sudo su, you have to become a root user. Type the command called install and httpd-y. I'm just trying to install the web server now. Okay. Now once you install the web server, now every web server have a default location. So where exactly you're trying to keep all your source code. So when you go to here and try to see what is the default path for the HTTPD web server. It is a var www HTML folder where by default it is available your all the files. So now if you just go to here, now if I go with the cd /var, go to www folder. www stands for the World Wide Web. So once we install the web server, then only we can able to keep, we can see that www folder. Inside that I have to go to HTML folder. Now type the ls command. See, we don't have anything right now here. Now what I can do, I'll deploy one application over here. So what I can do now, I'll go to my GitHub repository. There is some source code available in my GitHub repository. Let me clone that code into my virtual machine. It is. Let me go to my repositories. Okay. And here we have to go with the application. Let me go with the application. Let's go to the test, I think, web app. Yeah. So this is a simple application which I have right now. And going forward, you will understanding about how to work on the data architectures. If you just go to here now, let me try to install the Git as well. Now type the command called install git -y. Now hit the enter. So I'm trying to install in the Git right now. Okay. Now let me go to the, I'll go to my inside the ACT user. Okay. Now here, I'll try to clone this repository. The repository name it is called it as a test-web-app it is. Now when you type the ls command, if we go to the test-web-app, you see that you're going inside this particular folder. When you type the ls command, we have all these files, right? So now we have to copy these files inside the my path it is called as a var, go to the www and go to the HTML directory it is. Okay, sorry. It is index.html page, the file name it is. Now hit the enter, go to here. Now it's got copied here. And the same thing, I'm trying to copying all the files in a location where I want to keep all my files. Because it is the default location where exactly we have to keep all your files. I'll go to the cloud and services.html. This is also going to be copied. Now other file name it is called as a contact.html page. And this file also I'm trying to copying over there. So go to here, contact.html page also I'm trying to copy this. Okay. Let me clear my screen. Now if we go to the, let's go to here, sorry, cd /home, go to the EC2 hyphen east. Okay. Now, if I go to this particular location, where www HTML folder. Now here I have all the files. You see that we have copied all the files inside my HTML folder. So whenever you want to get this web application through the web browser, basically we have to start your server. So how can we able to start your server? So when you type the command called service here, service httpd start now. Now once you hit the enter, you see that it started your server. If you go to here, when you type the command called the status now, you see it is active and running status. That means my server it is actively running status it is. Now, if you want to access this response to your request, we have to open the port number 80. So now if you just look at here, web server is a program that uses the HTTP hypertext transfer protocol to serve the files that from the web pages to the users. Now, whenever you want to expose the application outside the virtual machine, definitely we require this. We require the IP address. Now, if we go to now, there are two different types of IP address we'll be having. One is nothing but a public IP address. One is nothing but a private IP address. Now we have deployed this application in the web server. Now, if I go to now, let's go to this application instance ID. And if I go to the public IP address, copy the public IP address. Now here I'll go to now, and I just going to keep this IP address and port number it is 80. So if I don't pass, if I list for example, if I pass this IP address or port number, you see that whether you are going to access your application or not. So it is going to tell you that site can't be reached because you haven't opened the port number on your security inbound rules. Let me open the security port number. Not only this, any server which you want to access through the web browser, we require a public IP address. So we don't use public IP addresses. I mean to say in the real-time examples, we'll go with the elastic IP addresses that I will discussing about later. When you go to security groups now, and when you come down here, go to the 8 inbound rules. Now here we have to click on the add rule, and here we have to go with the all TCP, or if you want to specifically open the port number 80 HTTP protocol, you see that I'm trying to open the HTTP hypertext transfer protocol. The port number for this, it is 80. Let me open this anywhere IP4. Now we have to click on the save rules. Now I'm just trying to open the port number. Now, if we go with the same request, now you see that your application is got loaded. So it is a home page and we will be having these about us space we don't have. Now, if I go to the cloud services page, we'll be having right now. And if I go to this contact us, you'll be having this particular contact us information. This application we had deployed in a server. So I hope you guys clear with this example, right? Now the same way, I'm trying to configure the other servers as well. Let me configure. But this time what I will do, I'm trying to deploy a different application to showcase you guys how this application is going to work in different servers. Let me go to my web server 1 and try to connect my web server 1. Click on the connect. Now I'll go to the EC2 at the read DNS name. Go to the right click, go to the new session, go to the host name, go to the appearance, click on the change. Now here we have to go with the 14 here. Now after this, we have to go with the connection here. Let me go to the 60 here. Okay. And try to connect the credentials. The same key pair for two servers. Let me go with the Citibank Jenkins. Okay. Let me change the color to identify that which is my web server 1, which is my web server 2. Click on the change settings. Go to the colors, foreground, click on the modified. I'll go to this option here. Now click on this apply. That's fine. This is now server 2. Let me go to the sudo su. After that, type the command called yum install. We'll try to install we are trying to updating my operating system first. Type the command called yum update -y. I'm trying to updating now. Okay, now here. So we have to install the web server. Same steps we have to follow that. Yum install httpd-y. You're trying to install the web server. Where www HTML folder. Now type the ls command. You see that we don't have anything. Now this time what I will do, I'll try to deploy the different application. So let me create the index HTML page. Press I button. Sorry. Press I button. Let me get some code from the Google. Okay. Let me go with the static web application source code. Let me get the source code now. Click on try yourself and get the source code. It is Control A, Control C. Go to your instance now. Now here, open this. So paste the source code. Escape :WQ it is. Now we have to start the server. Service HTTPD start. You have to start your server. Now check this whether you are able to access this application or not. I'll go to different web window. Go to instance ID, public IP address. I have to go with this now. Let me go to this now IP address. It is 80. Now hit the enter. Check whether you are able to access or not. Yes. Now look at my screen. This applications, whatever I deployed, even you guys can able to access. So why? Because I have deployed this application on the cloud so that anyone can able to access from anywhere. I'll pass the URLs in the chat box. You guys can able to access my applications. Let me go to here and let me pass this URLs. So both servers are running right now. And here, what I can do, I'm trying to start my server automatically. I don't want to start my server manually. Check config, HTTPD on command, it will start your servers automatically. Okay. Now, let me go with the other server and type the command called chha config HTTPD on. Now hit the enter, you see that it's going to be started. Now what I can do, I just want to, I just want to now set up the load balancer. Now, as per our diagram, where is this diagram? Yeah. So as per this diagram, now this two steps is done. That means we deployed two servers and we have the application ready now. Now we want to distribute the traffic between the two servers whenever my customer is going to access my application. Now how we can do it right now? We have to set up the load balancer. Now how can we able to set up the load balancer? See, manually we are setting up the load balancer, but in real time we have a different use cases. I'll explain that. Let me go with the load balancers now. Now we can see that we have discussed about what two use case of the load balancers. There are the two load balancers. Still it is running in my, let me go with here. Go to the actions and click on the delete load balancers. Otherwise, I think it will be a charge. Click on the delete. Okay. Now I don't have any load balancers in my this North California. Let me create a load balancer first. So we have to select what is the load balancer which you want to create. Now here we are trying to creating the classic load balancer. If you just look at here, choose a classic load balancer when you have existing application running on the EC2 classic network. Now click on this create now. And here we have to provide the what is the load balancer name it is. The load balancer name could be anything. Let's say, for example, I'm just going to provide the DevOps demo session. Now, here we had to mention about the what is the scheme it is. See whether you are getting traffic from the internet or you are setting your load balancer for the internal purpose. So I'll go to the option name. It is called as the internet facing here. See, an internet facing load balancer route the request from the clients over the internet to targets. So what are the requests which is coming towards your application? It is going to accept the incoming traffic, and it is going to route this particular traffic to a particular IP address. Now, if you just come down here, we have to go to the option name. It is called as a network mapping. Network mapping is nothing but in which network you want to create your load balancer and which VPC you want to create your load balancer. That is what basically we have to understanding about the network mapping. Right now, if you just look at my screen, I'm trying to set up this my load balancer on the two subnets here. One is nothing but US-West-1B. One is US-West-1 CDs. Because wherever your EC2 instance is running and which subnets you are running, and the same subnets we have to configure your load balancer. So otherwise, we can't able to distribute the traffic between two servers. Now, when you come down here, security groups. See, we required one security group where it is going to be talk to your instances. Security group at nothing but set of firewalls. It contains the inbound and outbound rules. So let me go to here. The security group name, I'm just going to provide the DevOps-demo now. The description also I'm giving it is DevOps here. After that, in which VPC you want to create the security groups? See, I have right now two VPCs, I think. Yes, I'm going to creating the default VPC. Now click on the add rule here. The rule name, I'm going to open the SH protocol to connection this, select the anywhere. Also, I'm trying to open the HTTP protocol as well. HTTP and go to here, click on this anywhere it is. Now this two security group it is got open it is. One security group and two protocols. In outbound rules, we are trying to open this all traffic here. Now click on this create security group. This is done it is. Okay. Now we have to attach the security groups to your load balancer. How we can do it? Click on the refresh now. And here we are going to get the DevOps demo security group. You see that? Don't delete the default security group. And after that, we have to come down. We have to select this option name. It is called as a listeners and routing. How we are trying to route your traffic. What is your listening port number? That is what we had to mention. This is nothing but my port number, it is 80, which is going to accept my traffic, whatever it is coming towards my instance. This is what we can call it as a service port number. Now, here we can see that health checks. So what is the second point which we discussed load balancer? It is going to check the health of the server before it is going to send or route the traffic to a particular server. So why? Because let's say, for example, my end user sent request to access the application. The request go to load balancer. If this server it is not active status, okay, the server is not active status. If my load balancer sent request to this particular server, you're not getting response. See, if it is server is not running status, how can we get a response here? My end user think that application has some issues. So he will go to the computer website. Instead of Flipkart, now it will go to the Amazon website. That means I'm losing the customer. When I'm losing the customer, that means I'm losing money. So in order to keep up our application and in order to get the response to your request, before you are going to send traffic to your particular server, we want to check the health of the server. Now, how we can able to check the health of the server? It is, we have to go to this option. We can see that there is something it is called as the instances. Now we want to, before you are trying to add the instances, now what I can say that we have to click on the advanced health checks. Okay. See, response timeout. Response timeout means whenever my load balancer send request to server, within how much time it has to get the response. That is what we can call it the response timeout. Now, if we go to my here, see the response time in 2 seconds. Let's say, for example, I'll change the 5 seconds. That means within the 5 seconds, I should get respond to my request. Now, okay, fine. You're getting response within after the 5 seconds. Do you think that every time you're getting response to your request? No. So how frequently you want to check the health of the servers? See, for example, it is not one-time activity, right? So every day my servers are running my production environment. The customers are going to access my application. So we want to check the health of the servers. So every 5 minutes, sorry, every 5 seconds or 10 seconds, we want to keep check frequently my health of the server. Let's say interval, I'll give you the 10 seconds here. That means every 10 seconds, my load balancer is going to check the response to my request. So it is going to send the ping request to my server. It is check the whether I'm getting response or not. See how it is going to check the health. It is because it is going to use something. It is called as a ping protocol. It is going to send the ping request to server. If it is getting response from the server, that is fine. If we go to here, you see what is the ping target it is. So it is going to pinging your home page or your application. This is the health check ping is set using the protocol and port which you're going to specify. If you are going to use HTTPS protocol, you must also provide the destination path. The which page it has to be ping. Every web application, it contains the home page. That is what we can call it as an index page of the application. Now, unhealthy threshold. See, for example, I want to decide that this server it is a dead or this server it is not it is not healthy it is. Now, how we can able to check that? How we can able to identify this? That is the reason only we had to set something. It is called as a unhealthy threshold. Threshold is nothing but target. Now, for example, the first time I'm sending the request to my server, it is not giving response. See, I should not decide that this is an inactive status. Again, second time also, we have to send the ping request to my server. And then if it is not giving a response to my request, then we can decide that this server, it is an unhealthy server. So my load balancer will not route the traffic to the unhealthy servers. It will route the traffic to only healthy servers. If the server is healthy, if it is getting response, then only it will send the traffic it is. Let me go to here. I'll go with this unhealthy threshold. I set the true it is. That means the number of the consecutive health checks. The number of consecutive health checks is get failed. before declaring EC2 instance is a unhealthy. Now we have to go to the option name. It is called as a healthy server. So we have to declare that. How do you going to decide that this instance as a healthy? How can we able to decide that? So that is what we have to understanding about healthy threshold. That means the first time you are sending a ping request to your server, you are getting response. Second time also you are sending the ping request to your request, it is getting response. Then we can declare that this instance is a healthy instance. Okay. So this is we have to set manually. Now, if we come down, I'm going to attach my servers to load balancer. See, you can add EC2 instance registered to your registered targets of a load balancer. Now click on this add instances now. I'm trying to attach this two instance to my load balancer. Click on the confirm now. You see that? See, we don't do that in the real-time application. Manually, we don't attach instance to your load balancer because the based on the traffic, it has to increase the number of servers, it has to decrease the number of servers, and it has to increase the number of servers. This concept, what we can call as auto scaling. In auto scaling, we have to perform the scale up and scale down because we don't know when my traffic it is going to be increased, when my traffic it is going to be decreased. See now, after your load balancer created, we can add the Amazon EC2 auto scaling groups. This is comes under the auto scaling concept. I'll explain about how we can able to perform the auto scaling on AWS. See that the number of EC2 instances are how many we require to load to handle the load for your application. Okay. To decrease the maximum fault tolerance, we recommended to maintain the approximately equivalent number of instances for each availability zones. Now come down here. Now it is already everything is set ready to create my load balancer. You see that the first we had to provide the name of the load balancer. Then we had to mention the scheme. It is called internet facing. Then we had to go with the network mapping. I'm setting for load balance in these two availability zones. In the security group, I attached this particular two protocols. One is SH and HTTP. After that, this is my listening protocol. When ping request is going to be sent to this particular listening protocol. Health check, you look at the path it is going to be ping it is. What is the settings here? And after that, if you come down, you see that this is the number of instances what you have created. Now click on this option name. It is called as a create load balancer. You see that I'm just creating my load balancer. My load balancer is got created. So as of now, I don't need to provide feedback. So when you click on now, you see that load balancer created. Now, when you click on this checkbox here we have to understanding about some rules, or you have to understanding about some of this particular information. So when you come down, you see about what instance we have, what type of load balancer you created, how many type of instances we have attached here. Now, when you come to this option called as a target instances, this target instances is going to be now it should be out of service, right? It should be active service. So when it is going to be in service, then only it is going to be receiver traffic. It is taking some time. You see that instance registration is progress. And after that, if we go to this option called listener, which protocol it is going to listen it is. Port number 80, which we have defined. And go to networking mapping, security. See that we have attached the security groups called DevOps here. And health checks. See, whenever you want to modify details, we can able to modify by using the 8 option here. Even if you want to add this, also we can able to add the number of instances as well. Okay. Now let me just go to here and try to understanding about the how do you going to provide it. Let me go ahead and try to understanding about the how we can do it now. Now after that, so when you just come down here, let me check the target instances. My target instance is still it is out of service. When I click on the refresh, check the health it is. Now it is become the in service. Now that means my load balancer is active right now. And if we want to access this load balancer, we have to go to this option it is. So it is going to provide the DNS name. Now I have to go to this option called DNS name, copy the DNS name, go to the web browser and try to access your load balancer. Now hit the enter. You see that you are able to get the responses. So let me just going to explain about the how it is going to distribute the traffic it is. So it is taking time to load your load balancer. You look at here, this is nothing but my load balancer name. It is called DevOps demo. And so this is going to be listen the port number 80. And look at here, we'll just wait for the fraction of seconds so that my load balancer is going to be up and running. Before that, if I go to this instances now, you see that there is a instances. If you want to see that where this actually where actually your instance is running, it is running on this particular 1A and 1B, right? But when you go to your load balancer, you see that where you have set up this load balancer. When you go to the availability zones, see 1B and 1C in these two availability zones which we have set. So I mentioned the point that if you want to set up the load balancer, the first we have to check that in which availability zone my EC2 instance are running. The based on that only we had to set up the my EC2 instances. Let me go to here and here let me try to access now. Check that we are able to get the response or not. Okay, now you see that you're getting response. Now, whenever I send the refresh now, that means I'm sending one request to my load balancer. Click on the refresh now. You see you are getting different response now. When you click on the refresh now, again you see the different response. That means load balancer, it has their own algorithms. Now it has something, it is called as a round robin algorithm. Round robin algorithm means the first request go to first server, second request go to second server. Like that, it is going to distribute equally a traffic to the all the servers. You see that? So even if you guys can experience this, I'm going to share this in the URL in the chat box. We can go ahead and try to access my load balancer. Check now. Are you guys able to access this load balancer? If you are getting responses, same responses, please let me know. Anyone getting responses? I see no one is giving responses here. Are you guys able to access? Yeah. Now what I can do, I'll go to one instance now. Let me go to my instances. I'll stop one instance, okay? Let me go with the instances here. I'll stop the web server one. I'll not terminate, I'll just stop instance. Okay, let's see now what response you are going to get it. Now click on this refresh now. See, it is just stopping my instance. It is going to be stopping right now. Yeah, now if you go to my load balancer, when I click on the refresh now, you see that when you send 100 requests also, my load balancer will not send a traffic to the unhealthy server. You see that? If you click refresh 100 times also, the requests go to only one server. Even if you go to your load balancer here, you see it is going to be like out of service. When I click on this now, if I go to here, when I go to the target instances, you see that one instance is going to be, when I click on the refresh here, you'll get the status of the servers. Refresh now. When you come down, you see that both are it is showing about in service and one service is a Web server 1, it is out of service. That is the reason only my load balancer, it is not redirecting this traffic to this particular load server, web server 1. If I go back to EC2 instances now, let's see how a load balancer automatically detect the health of the server. Now I'm going to start my server again. Click on the start, click on the refresh now. You will see that whether your application is running properly or not. Now you are getting second response or not, we'll discussing about. Now click on the refresh here. Now here click on the refresh again. Refresh again. See, now it is back to the running status. Back to the running status. It is going to identify automatically. Click on the refresh now. Yeah. Now go to your dynamic your load balancer. Now click on the refresh now. Say click on the refresh. Now it is started giving the second response as well. So my load balancer will automatically check the health of the server and it is going to distribute a traffic equally to the all the servers. This is what basically we have to understanding about how we have to configure the load balancers and how we have to see practically it is going to distribute traffic between the all the servers. So clear? Anyone have any questions now? I got only one response. What about others? This all the topics will be covering again. Right now, try to understanding about the how it is going to be work. See, with this today's session, all the demo classes got completed. Okay. So we did with all the demo sessions. And from Monday, we don't have sessions on Saturday, Sunday. Our class timings from like Monday to Friday. We don't have sessions on Saturday, Sunday. So now from Monday, our actual classes will start. We are going to start from the basics. If you're from non-IT background, you don't have any experience in IT, even if you don't know about cloud, you don't know about Linux commands, nothing to worry about it. I'm here to help you to make you understanding about why do you require Linux and how, what is the commands we are going to use and how to work on the cloud and how to work on the DevOps tools. So I think already everybody got syllabus. So if we are not going to receive the syllabus, I'm just going to reshare the syllabus, what actually we're going to covering in this particular the sessions. So from Monday, we're going to start the actual classes. The class timings will be the same, 7 a.m. IST to the 8 a.m. IST. So when you ask more questions, it will go to the 8:15 or 8:30. Depends on you guys how you are trying to practicing, how you are going to ask the questions. See, we'll be having a dedicated questionnaire sessions where you can ask all the questions, whatever you practice on a particular week. And we'll be having a separate team. Whenever you're practicing something, you're stuck somewhere, you need some assistance. We have a team. Definitely the team, it is going to help you for your doubt clarification, everything. And as I said that once we are done with this 3 months course, okay, and if you want to work on the client products, we'll be providing the internships. We'll be providing 3 months internship. This 3 months, you want to come to the offline, also it is available. If you want to do it online, definitely also we can able to help you for the online internship as well. This is a 3 months internship we are going to provide. Okay, this is the complete roadmap about our classes. So our specialization is more on the Docker, Kubernetes, Jenkins, Ansible, and Terraform, and Grafana and Prometheus. So these tools are very, very important when you want to become a DevOps engineer. If you don't know about Docker and Kubernetes in-depth knowledge, I'm sure that if you attend 100 interviews also, you can't able to crack the interviews. These are a trending tools nowadays in the market. Okay, so we had to focusing on these tools more, and we'll see that how practically you are trying to implement in the real-time projects. So we'll be taking this 11 microservices, 10 micro applications, 7 micro applications. So we'll see that from the scratch, how we are going to configure, how we can able to work on these applications. So everything you're trying to understanding from the scratch. Okay. So if you have any questions, you can ask. I'm just going to clarify your doubts.